all right, I want to put all this together, all the stuff we've talked about for this unit, into one video here so we can actually see what all these steps are and what we're actually doing in a hypothesis test. So first step, unfortunately, is the one that people skip over far too often, which is defining clearly what statistical question we're trying to answer with the hypothesis test. So unfortunately, very often with my consulting, people bring me this data that they've gathered, usually with a lot of time and expense to do that, without a clearly defined goal of what they were trying to do with the data. And once they actually do, after sitting down with me, figure out exactly what it is they tried to show, sometimes they didn't even gather the data they needed, or they gathered like half of what they needed, and now they got to go back and gather more. And it's kind of a mess. This should have been the very first thing we do. And remember, a statistical question is something, one, where I need to gather data in order to get an answer, and two, there's got to be variability from sample to sample. In other words, there's going to be variability from sample to sample in what kind of conclusions we make. Well, let me give you a quick example of how we could go awry with this very easily. So I could say, which gas station in town has the cheapest gas? Well, if I go out and look today, that's not a statistical question. One place will have the cheapest gas. And I don't care if you look at all the data or I look at all the data, one of them is going to have the cheapest gas. There's no variability there. Now, if I said, which gas station in general has the cheapest, average price, right? So I want to look at, historically, I'm going to take a sample of days and see which place had the lowest average price. Well, now, depending on which days I looked at, one place might be cheaper than the other, but I'll get different outcomes depending on that. I'll get different means depending on that. So I need to actually get some kind of random sample from place to actually do that. I ran into this issue with some project data where some people had looked at which model of car, and this was data for a particular year, and it was miles per gallon for particular cars of that year. And the miles per gallon is like a set posted thing, they go and they do very strict, the definition of miles per gallon is very strict. If you ever look up how they have to test it, there's not going to be any variability there. And they just figured out which model of car had the lowest miles per gallon. Well, that's for a particular year. It just is that. That's not a statistical question. There's going to be no variability. So these statistical questions are very important. Unfortunately, they're skipped too often. If I actually looked at a bunch of years and I said, well, what manufacturer of cars? Well, now we've got different models of car each year, right? Different performance packages, and things change from year to year, what engine they put in it, these kind of things. Well, now I might get some variability. If I'm looking at one particular year, one point of data, there's no variability there. I can't do anything with that. So I got to start with a real statistical question, which for us in this course is always going to be about, or at least, for these first several weeks, looking at this is going to be about the value of a particular parameter. We're just going to expand on that to be able to compare different parameters as well. But for now, it's going to be what's the value of this parameter, basically. Now, after that, I want to clearly state what my hypotheses are going to be, and specifically which of these two competing claims are going to be the null and which one's going to be the alternative. And clearly write out, now, because we're in a statistics course, we'll use math symbols for this. But moving forward in any kind of research methods course or something like that, you'll put it in words, but we need to be clear about what parameter it is I'm investigating. In other words, what thing about the whole population of all individuals is it that I'm investigating, and what value is it that I'm going to be comparing it to. Next, I want to set the level of significance for the test. Right? So this is usually set for me, but I need this set now. I don't want to change it later, right? So if I get a p-value of, 0.06 or something, I don't want to decide, oh, well, I wanted to show the alternative is true, so I'm going to make my significance level 0.1 so that my p-value will be below it and I can show that it's true, right? I can't have my p-value before I have my significance level. I need to set that first in order to actually ethically do any research. So after I've set the significance level, I've decided what my hypotheses are, what question I'm trying to answer. Now I gather my data. I don't want my data to be influencing what my question was, what my hypotheses are, and what my significance level is for the test. If so, I run into all kinds of dependence issues where, like, my decision of what I'm going to investigate and how I'm going to investigate it is based off the observations I've made. Well, now all my conclusions are invalid, essentially, and probably not reproducible. So from there, I want to compute a test statistic. Remember, this is just an intermediate step to calculate the p-value. So this is not something I interpret directly. It's something I use to calculate a p-value, which is this step 6. So I'm going to, after I compute that p-value, I'm going to just make the decision for my test by seeing whether my p-value is less than that significance level or not. Once I've made my decision, now I want to go back and put my conclusions back in the context of my statistical question that I was trying to answer. So just like I insisted that we report certain things with confidence intervals, specifically the confidence level, what it is I was actually estimating, what the actual estimate is, and just units, throwing that in there. I'm going to have the same kind of basically stuff here. I want the parameter and claim we tested, right? Like the mean was more than 5, right? I wanted to see if the mean was more than 5. What decision I made, which would be I decided that was true, or I didn't have enough evidence to show it was true. And then either the p-value or level of significance. Either one of these is acceptable. Either one of these is a measure of how strong the evidence was. Okay, so now that we've done that, I just want to do one example where I go through all the steps that we would need to go through in order to actually conduct a hypothesis test for this class. Obviously, we're not going to be going out and gathering data after being given the level of significance. Things are going to be a little bit out of order here, where we're going to be given data and then work with it. But I will tell you ahead of time, like, the problem will say what we should have set as our significance level and what we should have set as our hypotheses in it. And again, I just want to have a nice, clear example of putting all this together now that we've at least put it together to see what the steps are.